Okay, morning everyone. Welcome to this session number 462. And today I have this problem. It's a daily challenge. Um, it's the first time. Yeah. Okay. Maximum of a pairs with equal sum digits. Okay. You are given a zero index array nums consisting of positive integers. You can choose two integers I and j. Okay. Such that I is different than j in this uh, in the sum of digits of the nums in index I it's equal to that of the nums in the index j. Return the maximum value of nums I plus num j that you can obtain over all the possible indices I and j that satisfy the conditions. Okay. In this case, I have the first example is 18. Okay. Before this, I will check the constraints. The nums, the minimum, okay, all the numbers are positive, starting in 1 and ending this, and the length, sorry, is at least 1, and the maximum is this, and the values in the array is the same. The minimum is 1 and the maximum is this. Okay, well, got it. Now, now I have 18, 43, 18, 43, 36, 13, 7. Okay, in this case, we need a pairs, I and J, the index pair. I and J certificate. 0 and 2 means that between this, okay, this is the 0, 1, and 2. And let me check. You can choose two integers, I and j. In this case, the I is the 18 and j is 36, such that are different, yeah? And the sum of digits of the number I and the sum of digits. Okay, got it. Yeah. Because, for example, the 18, if you apply the sum over the digits of this number is 1 plus 8 is 9. And 9 it's equal that 3 plus 6 is 9. Return the maximum value you can obtain over all the possible indices I and j. Satisfy the condition. Okay. I have the meaning of this. Okay. Okay. Sorry. And is return the maximum value that this and this. For example, in this case is 9 plus 9 is no is I need to sum the number with another number. Well, I think that in this case it doesn't matter the order, because if appear, for example, do you imagine that in this is one example, okay? In this case is this. Do you imagine that this is, for example, 1, 8? Again, is one example. 8, and this is 3, for example, or well, 7, whatever. In this case, for example, it doesn't matter where appear the first, or in this case, it's not necessarily identify this as a I, and this is as a J, because if appear one or more times, in this case, if appear 2 times, obviously, in for example, the 18, so you imagine that here, the 9 appear one time here, and appear another time here, yeah? I don't need to know in which indices appear, because on the final, if I transversal this, mapping these values here, I'm sure that are different. Yeah, it's not the same. For example, if another appear like this, well, it's another. Yeah, but it doesn't matter the identify the I and J. I think until now, I think I understand this. Another thing is that yeah, I can yeah, for example, if I start for example like this, and the first is this whatever. Well, in this case, this the sum of this is 1 plus 8. It's equal 9. 9 is here. No, okay, you can create this, and okay, but yeah, I need maybe I don't need to identify that is I, but I need to know what is the value. In this case, I think that we can use a list here. In this case, for example, the index the index is 0. Okay. Now the next is 43, and 43. In this case, for example, 43 is 7. 7 don't appear here, and the index is 1. Got it. Now, the next that is this. 36. 36 is 9. In this case, we have 1, 9. Yeah. Okay, means that 18 plus 36, it's equal, what is the result? 54. Now, the maximum value that I reach is this, 54, okay? Now, moving with the next, it's the same. But in this case, what happened, for example, here, if I appear another value here, that the sum of the digits, it's 9. For example, like this, yeah? In this case, if previously I had the result is 54, yeah, because this is the result of sum 18 plus 36, because this, if I sum the digits, it's equal 9, and this is the same. For example, this is another combination, yeah, and in this case, I need to check which combination have the greater value, if this 19 plus this or 19 plus this. Well, I think that is easily to discover that. I only need to override all the time. For example, if appear here, sorry, here, 19, yeah. Yeah, I think that with that, when I take it here, it's okay. The first time this is the result is 9. 9 appear here. No, okay. And the maximum value is 18. Okay, got it. Now the next that is 7, because 4 plus 3 is 7. And the maximum value is, well, in this case is 43. Sorry. Now the next that is 9, because 3 plus 6 is 9. Okay. And in this moment, for example, I found this is 18 plus 36. It's equal 54. Yeah, this is our current maximum. And in this case, I need to decide, or I need to put in this value the maximum value that I reach with this. In this case is 36. In this way, where I reach this value that again is 9, because it's 9 plus 0 is 9. I can make this operation with the maximum value that I reached previously. Yeah, I think that could works, but let me check the acceptance rate. Well, have a higher acceptance rate. I think that could be works. But let me check another example here. For example, and okay. Well, in this description, not mentioned that if it don't satisfy the condition, return less one. Okay, got it. Now, let me check here. Okay, now, ah, okay. Now, in this case, we have our hash map here. And now the first that, the first is one appear here. No, okay, the maximum value is this. Now the next that is this 12, 1 plus 2 is equal 3. 3 don't appear here, and the maximum value is here. Now the next that is this is 1 plus 9, it's equal 10. 10 appear here, no. Now the next that is 1 plus 4, it's equal 5. 5 appear here, no. Okay, in any moment I return or I find the maximum means that is less 1. I don't know. Looks like as a easy problem, but usually this problem have a trick. But well, let me check. Hash map, integer, map, it's equal new hash map. And maximum. Integer max, it's equal less 1. Okay. Return max. Now 1 4 here, integer n nums, and the first is ask if map dot contains key n, where is not contained no, where is contained, I need to calculate the sum of, no, in this case this is wrong. I need to sum the digits. I need to sum the digits, and sorry. Okay, I have this. Okay, now, okay, I need to sum the digits of this. In this case, I think that I can create, I can cast this as a string in transversal, but well, I think that's private integer, it gets sum of digits. Yeah, in this case, this return receive a number n, and integer result equals 0. And in this case, we have this integer, no. Uh-huh. Okay, and here I need a while. In this case, meanwhile n it's different than 0. The first is get the last element in the of the n. For example, if n is equal 88, I need to divide. The first is get the module of this number module of 10, because our numerical system is decimal, means that 10. Yeah, in this case is result plus equal, yeah, n module of 10, always is of 10, not necessary. In this case, for example, 18 um, module of 10 is 8. Get the last digit. Okay, now is the last digit plus equal 8 is 0 plus 8 is 8. And now is n divide between 10, and in this case is 18 between 10, it's equal 8. Yeah. No, is no, yeah, I think that should be works here. And the final is return result. And now here, where happen this is max, it's equal math.max, no, max. Math.max between max and uh, n. No, 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 no. This is wrong. Here is integer sum, it's equal this. In this case, for example, the first number is 18, the sum is 9. I need to check if 9 exists here. If exists, I need to sum between the current number plus map.get and this value. Yeah, and this is the real result. Now it's max, and here now map.put sum, and here is map.get or default. Yeah, sum, this is the default, sorry, is 0, and I can math.max because I need to save the maximum value, and it's between this number. For example, if the map contains the register, the key 9, and the value is, for example, 18, but appear another that is 9 plus 0, that is 19, the maximum value is should be set to the map. And that's it. 61. Wait, why appear this 61? Why? Okay, 9, 7, 9, 4, 7. Mm, I only have though here. Let me check. Maybe this is wrong. I received the 18. Mm, mhm. 18. 18 divided raised to plus equal 18 modulo of 10. It's 8. Now n it's divide equal 10. Mhm. Now if the map contains the man, because it's null. Ah, again this. And mm, well, I think that it's easy this problem. Uh, mhm. Simple solution using hash map. Mm, okay. Mm, okay, what is the solution? Sorting. Yeah, I think, but it's the first time that appear, but you need to process to apply the sorting. In this case, could we increase the time complexity? What is the time complexity of this? Yeah, n logarithm multiply for n logarithm n. In this case, for example, is linear. It's more faster, or is faster this compared with this pretty Q. The pretty Q. But the problem with using pretty Q, I think that is the pretty Q itself, because if you are using this for uh, keep in the top the maximum value, it's a logarithm n. Let me check. N logarithm m. No, it's not 82. A right to store the min heap for each possible digit sum. Yeah, because the length of the no is too much here. Store maximum value. Okay, this is interesting because the array map in the year 82. Okay. Well, I think that is similar that the map, but don't have any difference. And the final, the time complexity hash map operations is constant. I need a table. Time complexity algorithm. No, but for the operation, here, get constant contains is constant. For the insert is constant. Yeah, don't make sense. Don't have any difference with the array in these time complexities. Well, I think that where you have defined this size, this is the maximum value or the maximum space that you can reach, and with the hash map need increase, but no, in this case, yeah, in logarithm n, and with the hash map, mm, okay, I will check another solution. Mm, yeah, okay. Now, mm, okay, mm, oh no no no, uh, card, no, I want another one medium. I need to check what is the next topic in my Ready. I complete all the problems in Ready. Let me check. Maybe no. Oh, 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 oh. Hmm. I had the idea that I complete all this section, but no. Uh, okay, the next is the binary search. Uh, the backtracking and the dynamic programming. Okay, I am very close to complete this course. Okay, well, I think that it's a little late to me. I need to start to work, but well, thanks for following this transmission, and I hope see you in the next. Bye bye.